Welcome to The Explainer. Today, we're taking a deep dive into a massive global transformation that's happening right under our noses. We usually hyper-focus on the software side of things, right? The algorithms, the chatbots, that sort of digital magic. But today, we're going to uncover the massive, resource-hungry physical footprint quietly reshaping our world to support AI. We're exploring how AI is fundamentally redrawing the physical map.
So, where does artificial intelligence actually live? We use phrases like saving it to the cloud all the time, and honestly, it creates this incredibly persistent illusion. It kind of makes us feel like AI is just this ethereal software floating invisibly up in the sky. Well, let's shatter that illusion right now. AI does not live in a cloud. It lives in massive, industrial-scale physical structures anchored firmly to the ground. We're talking enormous amounts of steel, vast quantities of concrete, and literally almost an unfathomable amount of electricity and water to function.
Okay, let's dive into this. Section 1, the birth of factories, moving beyond traditional data centers. To really grasp the scale of this physical transformation, we first need to look at the architectural evolution happening right now. We are moving way beyond those traditional enterprise data centers you might be familiar with. Those older facilities were usually measured in single digits, maybe tens of megawatts. Big, sure, but totally manageable. Today, though, we're entering the era of specialized AI factories. These absolute behemoths are measured in hundreds of megawatts and increasingly gigawatts, because the GPUs, those highly specialized chips training the AI models, generate so much heat under massive computational loads, traditional air cooling is basically obsolete. Engineers are now forced to build direct-to-chip liquid cooling right into the architecture, or even submerge massive server racks entirely in specialized fluids just to keep the hardware from literally melting down. And all this scale requires unprecedented resources, leading to a really striking geographical shift, 175 kilometers. Let's think about what that distance actually means. In Europe, traditional data centers used to sit right next door to major cities, about 46 kilometers away on average, just to minimize latency for their customers. Today, these massive new AI facilities have been pushed out to an average of 175 kilometers away, deep into rural areas. The priority isn't being close to the customer anymore. The priority is securing vast tracts of cheaper land and, absolutely crucial, a massive direct tap into national electrical grids. They've completely outgrown the cities. Actually, it's getting to the point where AI developers can't even just plug into the grid anymore. The grid simply wasn't built for this kind of immense localized draw. So what are they doing? They're literally building their own power plants. We call these behind-the-meter generation strategies, or energy islands. Tech giants are combining their data centers with expansive solar arrays, massive batteries, wind, and natural gas. They're even making huge investments to resurrect decommissioned nuclear plants and deeply exploring nuclear small modular reactors, or SMRs, just to guarantee the 24/7 baseload generation that continuous AI training demands. They're essentially morphing into independent energy providers. Which brings us to the consequence of this hunger. Section 2, Geography of Energy, the global search for power and water. This insatiable hunger for electricity is radically redrawing the global tech infrastructure map. Historically, computing revolved around established hubs. Think Northern Virginia, Frankfurt, Singapore. But today, power availability has completely overtaken location as the primary selection criterion. It's decentralizing historic computing hubs at a rapid pace. In Europe, capital is flowing into northern Sweden to tap its hydropower and into Spain for its vast solar capacity. Over in Asia, we're seeing aggressive expansion into Johor, Batam, the Osaka region, and rapid growth across India. The capital is going exactly where the power flows. And emerging markets are definitely not sitting this out. We're seeing exciting new AI centers sprout up across Africa, specifically in South Africa, Kenya, Nigeria, and Egypt. But, there's a harsh reality here. Their ability to fully participate in this global AI boom is heavily constrained. And the bottleneck isn't talent or ambition, no way. It's the sheer, uncompromising requirement for massive, uninterrupted electricity infrastructure. When a single facility demands more power than entire regional towns, the barrier to entry becomes incredibly steep. Now, what's really interesting about this is the incredible efficiency paradox we're facing. On the surface, it looks like the industry is making huge strides in sustainability. A traditional data facility used to have a power usage efficiency, or PUE, of about 1.6. But these highly optimized new AI facilities boast an incredibly efficient PUE of 1.15. That means almost all the power goes directly to computing, rather than overhead like lighting and cooling. Sounds like a massive win, right? Well, here's the catch. Because total computing capacity is growing tenfold, absolute global energy consumption is still skyrocketing. The individual buildings are way greener, but the total footprint is vastly, vastly larger. And it's not just energy, we absolutely have to talk about water. Those advanced liquid cooling systems we mentioned, they consume immense amounts of fresh water. To put that into perspective, researchers estimate that just a short conversation with an advanced AI model can consume a standard water bottle's worth of fresh water behind the scenes just for cooling. Because of this, water usage effectiveness is becoming just as politically sensitive as electricity. In drought-prone regions like Chile, Spain, and Malaysia, governments are being forced into an agonizing choice. Do they allocate scarce, precious water to cool AI servers, or do they prioritize sustaining local agriculture and drinking supplies?
Shifting over to geopolitics now, Section 3, the geopolitical equation, computing power as a national asset.
Because of these massive physical dependencies on water, land, and power, compute capacity isn't just an IT issue anymore. It's elevated into a strategic national asset, totally comparable to a country's deep water ports or national energy grids. We're looking at a brand new formula for national power in the 21st century. Let me walk you through it. It starts with Step 1, energy, which powers Step 2, specialized silicon chips, which process Step 3, massive data, transmitted via Step 4, fiber optics, all orchestrated by Step 5, human talent. Combine these 5 interconnected elements, and you achieve true AI capability. Nations are waking up to the fact that their global standing depends entirely on mastering this exact sequence.
Let's move to and see how this builds into Section 4, the sovereignty paradox, nationalizing the cloud.
This brings us to one of the most fascinating trends in tech today, sovereign AI. Nations are increasingly demanding that their highly sensitive citizen and defense data remain strictly within their own borders. So what is sovereign AI? It's the strategic development of domestic GPU clusters and dedicated government clouds to ensure absolute national control over data processing. The UAE and Saudi Arabia are prime examples here. They're aggressively building exclusive, world-class infrastructure for local government and enterprise use, making sure their critical data never has to leave their jurisdiction or pass through foreign servers.
But this pursuit of sovereignty creates a really glaring paradox. On one hand, countries achieve high security and absolute control over their national data. But on the other, they risk isolating networks and fragmenting the open global internet. And here's the real kicker. In their rush to build completely independent, sovereign systems, these countries ironically find themselves dangerously dependent on a tiny, highly concentrated monopoly of foreign hardware vendors, the very few companies that actually manufacture the specialized chips required to build these systems. Bringing this down to the human level. Section 5, investment versus local reality, the economic illusion. And this brilliantly illustrates the macro trend down at the economic level. Governments trying to capitalize on this boom often face an economic illusion. A country might successfully secure a massive AI factory, bringing billions in capital investment and splashing across national headlines. They frequently hand out massive public tax incentives to win these highly competitive bids. But unlike a traditional auto plant or semiconductor factory that might employ thousands, an AI data center is highly automated. It might only create a few hundred permanent jobs once the temporary construction phase is finished. So in markets like Brazil, Mexico, and Chile, local governments are having to carefully weigh whether those massive public incentives actually match the permanent employment generated for their citizens. Plus, geographic and physical realities dictate that not everyone can play the exact same game. Take Puerto Rico and the wider Caribbean, for example. They've got fantastic access to submarine fiber optics, which is a great start, but they face distinct, severe hurdles. Extremely high grid costs, critical hurricane risks, and a lack of freshwater security. They literally cannot simply copy and paste the sprawling data center blueprints used in places like Virginia or Ireland. To participate in the AI economy, these regions have to engineer completely unique frameworks, relying heavily on disaster-resilient microgrids, hardened telecommunications, and distributed renewable energy tailored to their specific environment. Wrapping this all together, Section 6, the new governance, regulating the AI infrastructure. So, the crucial point is, all of this staggering energy demand, the water consumption, the geopolitics, the local economic impact, it brings us to our final act. We are transitioning from simply building these physical factories to acknowledging an urgent global need for structural oversight. It really comes down to this one provocative quote.
Who controls the electricity, computing capacity, and data infrastructure? This is no longer just a technical question for IT departments. It is the ultimate geopolitical and environmental conflict of the coming decade. The power to control these physical resources is quite literally the power to dictate the future. We are now entering a new paradigm of AI infrastructure governance. This is a policy era that goes far beyond just regulating software algorithms. Governments must now implement strict, far-reaching oversight on water rights, energy allocation, compute sovereignty, and require direct community consultation before massive facilities are approved. The future of AI isn't just about elegant lines of code. It is about mastering the physical governance of the Earth's finite resources. So, as we rush to build the digital brains of tomorrow, what physical price are we truly willing to pay today? Think about that the next time you use an AI tool to write an email or generate an image. Until next time, keep questioning the world around you.